Welcome to Northwest Tech Show. I'm Dave Duncan, and this is a show where we talk about technology and how a better understanding of it can help you have better outcomes at home, at work, and in your civic engagements. We're going to kick things off, as we like to do, with a Creative Commons clip from the good folks at Twit TV.
This is Twit.
I guess the internet is getting more explicitly political. China has proposed a wholesale revamp, which other authoritarian countries, including Iran, Russia, and Saudi Arabia, have vocally supported. So there's actually been dialogue about this. There's quite a lot of heated rhetoric surrounding the topic. And, you know, as with contact tracing, where it's complicated, the rhetoric and the technology might be quite different from one another. So in working to get a feel for what was actually going on, I started with a PowerPoint slide presentation I found, which had been, well, it had been given during one of the workshops and seminars conducted by the ITU, the International Telecommunications Union, and it was done by the main architect, and mostly was sort of technological bullet points. It's not something anyone could implement anything from, but it's at exactly the right level to gain some overall understanding of sort of like what's the gist of this, which is, you know, my goal is to share that with our listeners. So for their key network technology requirements, they explained that they felt there was a need for more flexible, variable length IP addresses to adapt to diverse scenarios and to be backward compatible with IPv4 and IPv6. They also said support addressing and routing optimized based on communication entity semantics and something called digital twin relationships. Some time was spent talking about digital twins, but it was never very clear to me from the slides what they were. They're also trying to support real-time, what they described as large flux communication in virtual physical fusion scenarios, combining ubiquitous AI theory, whatever any of that means. There's a lot of talk about the future need for truly massive bandwidth and guaranteed low latency in support of, and I'm not kidding, holographic transmission and applications such as telesurgery. They also want secure, reliable, and resilient connection among massive heterogeneous networks, you know, why not, and future network architectures supporting multi-ID space and these digital twin relationships. So one thing that I think caused the hairs to stand up on the back of some people's necks was something that this system incorporates called identity-based routing. That is, as opposed to IP-based routing. So it's one of the most interesting aspects of this, and I think it's, as I said, what I think frightens people. The slides explain, instead of mapping all information into network addresses, diverse IDs are used to indicate the destination, which improves routing capabilities, unquote. In other words, this system proposes that it would be possible to address a connection to an individual based upon some sort of identity descriptor, and the network, necessarily knowing where this individual is, would route the connection to them. And of course, you can understand why that makes a lot of people uncomfortable. In order to do that, what you need to know, like where the person is. The slides explain packets are addressed by semantic content metadata, of which old-style IP addresses become a subclass. And examples of semantic content are given: content ID, device ID, people ID, and service ID. So, things have identifiers, and you can say, I want this to go to this device or this person or this service, and somehow the network makes that happen. They suggest that this would enable network layer deterministic forwarding rather than our current best effort forwarding, which of course is famously makes the internet go today.
Yeah. This is the antithesis of net neutrality. This is
yes.
the exact opposite.
Yes.
All bits
exactly,
are not equal.
yes.
All bits are unequal, and we can, do what we want with them.
Yep. Some bits are better than others. And the overall global network would be redesigned with a sort of super QoS, that's my term, a super quality of service structure, which they assert will be needed to satisfy future scenarios. So the network's available transit bandwidth would be divided into slices, and they suggest some examples. An AR/VR slice would have low latency, less than 20 milliseconds. What they described as a self-driving slice, and I guess they mean autos, would have a latency much lower than that even, of less than 5 milliseconds. And then a teleprojection slice would offer jitter of under 50 microseconds, so extremely low jitter. So the idea being you can somehow ask for different network characteristics and get that from the network. And a lot of this they then pulled together on a slide titled End-to-End Communication Requirements for Intrinsic Security, which is where they sort of are the most clear, and it's kind of chilling. They have authenticity, where they say more than 1/3 of autonomous domains right now, today, on today's internet, do not have prevention mechanisms for IP address spoofing. And so they don't like that. Accountability versus privacy, they talk about the trade-off. Exposing IP port and time to live on the wire decreases privacy, but anonymizing them decreases accountability. So they say IP headers design should take into account a trade-off between accountability and privacy, and you can kind of feel that they're willing to trade off accountability. That they're willing to trade away privacy for increased accountability. For confidentiality and integrity, they say the current key exchange mechanism has many vulnerabilities. What they described as intrinsic identity keys would be used, not relying on third parties, but there's no notion of how they pull that off. And then availability. Avoid the unavailability of target network resources, computing resources, storage resources, etc., caused by DDoS attacks. They don't like those. It is necessary to combine authenticity and accountability to build a multi-level verification filtering system for inter-domain and intra-domain traffic. So from this diagram, what is it? It's intrinsic security for privacy protection in future networks. It's a diagram that's kind of like got a beige background behind it and a blue box in the lower left. Anyway, they said, I'm saying, having looked at this diagram and studied it for a while, yep, that's the one, Leo. They said, so the system encrypts the sender's IP and the sender's local IP. They are then authenticated along with the hosting network. The traffic moves to the autonomous systems edge router, and we know what that is from the last couple of weeks. We've been talking about BGP, and autonomous system is like an ISP, and they have an edge router that connects their whole subscriber big network to the internet backbone. So the traffic moves to the autonomous systems edge router, which adds, then this is all new, of course, well, all of this is new, an ASID, an autonomous system identifier, which is generated by an HMAC. The traffic traveling over the internet contains this ASID verifier, an ID, and an encrypted IP. As the packet attempts to enter the destination autonomous system, the sender's ASID, that is the originating autonomous system ID HMAC, is authenticated to permit it to enter. Then its content is made available and the destination address pieces are decrypted. And what's most creepy is in the flowchart diagram, there's this overriding auditing agent, which is never described. It appears across the top with dotted red lines flowing down to all of the key elements on both sides. And in a box with a legend describing some of the abbreviations, the dotted red line is labeled shut off protocol, with not much else said. Yeah. Apparently,
you need to say no more, I think.
Yeah. Apparently, if the auditing agent is unhappy, that traffic does not flow. There's also ample attention paid to the needs imposed by holographic communication, which appears to literally mean the display of holograms. There's like a 3D body outline in one of the slides throughout the network. So they have ultra high throughput, customizable priority and strategy, reduced complexity, I don't know how that happens, and indeterminacy. Thank you.
It's indeterminate.
Indeterminacy. We're reducing complexity and indeterminacy.
We don't want that.
We don't want lossy transmission to affect the quality of content. And basically, they're changing everything. And inherent network awareness. I don't think they like our autonomous packet routing approach because it's too indeterminate.
You have to feel like the internet was designed exactly the opposite of this.
Yes.
For very specific and good reasons. And this just counters the whole thing.
Yes.
And who the hell's doing holographic communication anyway?
Yeah.
What are they talking about?
I really there was a sense that they were trying to use these really inflated future things.
Yes.
And then so we're going to have to change the plumbing.
Yes.
In order to support our future holograms, our holographic dictator.
Thank God we have holographic communications now.
Yeah. So anyway, that's a sense for what they're aiming at. The RIPE, which is the EU's internet governance body, blogged about this proposal under the questioning title, "Do we need a new IP?" That full blog post is long and winding, but the official response is short and to the point. Well, it's not quite as rude as saying no, but it's titled "Response to New IP Shaping Future Network Proposal." I've got the link to the PDF. It's only 2 pages. It reads, "During this group's last meeting in September 2019, a number of proponents introduced a proposal titled New IP Shaping Future Network, proposing what was described as an opportunity for a strategic transformation of the internet. The RIPE NCC appreciates the opportunity to respond to the proposal by means of this contribution. Since first being described in 1974, Internet protocol architecture has totally transformed our societies and economies as the design philosophy of an open and flexible Internet that has allowed for an unprecedented number of life-changing innovations. It is true that boosted by privatization and increased competition, these technological breakthroughs have also dramatically changed the telecommunications landscape. While it was once common to carry TCP/IP data streams across traditional PSTN infrastructure, those original telephone systems have now also evolved and are carried using the Internet protocol. In other words, it's sort of flipped it upside down. Throughout, instead of the TCP/IP being carried by the phone, now the phone is being carried by TCP/IP. Throughout its lifetime, the Internet protocol has also adapted to accommodate changing requirements and new technological insights. The most noticeable and impactful change was the redesign toward IPv6 with its 128-bit address space to overcome scalability issues and support growth beyond expectations. We believe it is exactly that open and adaptable nature that not only of the technical architecture, but also the surrounding governance models that is fundamental to the Internet's unprecedented success. Growing alongside its technical infrastructure, the Internet's governance model has also evolved to include new stakeholders and accommodate innovations, unforeseen use cases, and unimagined growth as the Internet became the fundamental technology powering our societies and economies. The open, inclusive, multi-stakeholder approach throughout its development, both in the technical forums that created its standards as well as the governance of its resources, has made the Internet what it is today. While we recognize the need for both the technical standards as well as these governance models to continue evolving, we strongly believe such evolution should take place from within the organizations and structures that invented the Internet and have supported its evolution throughout its history. We also strongly believe that any rationale for change must be carefully evaluated by all stakeholders in an open and transparent process to achieve consensus. The RIPE NCC is deeply concerned by what has been proposed here. We are especially concerned by the notion that this proposal represents an opportunity to steer away from the traditional bottom-up decision-making model. We also believe the technical rationale presented is flawed and find the suggested alternative designs to be both unrealistic and unproven. Furthermore, if any of the proposed solutions could be developed to a mature and production-ready standard, market adoption is very uncertain and would take decades to accomplish. The RIPE NCC is of the opinion that the proposal is premature and that following through with any of the suggested work would create significant overlap with the ongoing work of other stakeholders, in particular that of the Internet Engineering Task Force. Although some of the issues mentioned may warrant further study, we insist that any work on the evolution of the IP protocol layers and the associated technical standards be left to the Internet Engineering Task Force and be conducted under its governance. The RIPE NCC recommends that TSAG and the ITU telecommunications standardization sector in general not make any of the suggested changes to its structure or pursue any work items related to this proposal that would evolve the Internet protocol stack under the related to this proposal, that would evolve the Internet protocol stack under the ITU's remit. In other words, hands off. So that's what they had to say, not surprisingly. This is interesting, I guess, from a sort of theoretical what-if model, and it sure did ruffle, as I said, a bunch of feathers. But it's clear that those of us who have some deep affection for the operation of today's Internet, warts and all, have little to fear. Let's remember that we can't even get people to upgrade their version of TLS.
This would be a lot hairier. This would be a lot more. Yeah.
Oh, Leo, it breaks everything.
Yeah.
It would scrap the entire investment in all of everyone's existing Internet networking equipment. And I was thinking about, first of all, no one wants it. But if such a thing, maybe there would be a completely next generation thing once the holograms are, needing more bandwidth, demanding their own bandwidth. If such a thing should ever happen, first of all, it's a long ways off. And the only way I can see anything like that ever happening would be as an overlay of an entirely new next generation network, which would initially run in parallel and only in a few locations alongside today's internet. And it would gradually, maybe over time, eventually replace the older internet, which, come to think of it, is exactly the way the original internet was born.
Mm-hmm. Mm-hmm.
But, it was only connected a few things, and it, didn't try to replace the telephone.
Mm-mm.
And then it got bigger and it connected more and more places, and then it got more and more use, and it just sort of happened. So I could imagine some next net that would, happen sort of the same way. It would just, some people would start connecting things up, and other people would go, hey, we need to get one of those boxes if we want to play, with those holograms.
Consider the holograms, my friend. Consider the poor holograms.
You're listening to Northwest Tech Show. That was a Creative Commons clip from the good folks at twit.tv. That was Security Now 765 new IP. So that was both disturbing and reassuring to hear what the totalitarian governments think is a good idea for the internet. At least they kind of showed their hand. This is fortunately something that, as they were just discussing, the RIPE NCC and the Internet Engineering Task Force, probably not going to let anything like this happen. We've had a good long run of bottom-up design where the people with the most knowledge and the most influence over the physical architecture have to implement it are the ones that actually, decide what is needed and do so from a point of view of, what works best for all the stakeholders, not just the government. So this is a good approach. Just such scary things that they want to do, though, like, auditing agency and shutdown protocol. If there is a protocol to shut things down, it should not be done by some auditing agency. Because as soon as you create a valve like that, then the worst sorts of people want to be in charge of that valve. First it's, we're going to stop traffic issues, and then it's, we're going to stop, child porn or other criminal activities, and then it's like, anything that's really kind of dissent against the government is, needs to be taken out for, national security, and so on. So, right now, it seems like our best approach to doing things like taking out distributed denial of service is doing it at the local ISP level. Like, say if you're, say you're a cable internet provider is in a really good position. I mean, it knows physically where all the nodes are on its local net and what IP address they're supposed to be broadcasting from, which is kind of like your telephone number. And if you're sending out packets with a forged from address, someone else is like, okay, this is actually the IP address for whitehouse.gov or something. Your network provider knows that is not your IP address. And that's the level at which it should be taken out, I think. I can't think right off of any good reason for you to, say you're coming from some IP address outside your local net. I mean, even without knowing who you are specifically, it could say, you're saying a from address that is not part of my network. So right off, even without knowing who you are on my network, I know that's a bad address and it should be taken out. So fortunately for now, we've got a lot of, the infrastructure is run by a lot of the people that are knowledgeable and trusted to, do the right thing and listen to the various stakeholders, not just the government. Now, of course, those always going to have be set down some overriding orders, but for the most part, we've got some smart people that push back when pushed on these sorts of things, like we just heard about with RIPE NCC saying, the Internet Engineering Task Force has done just fine in adapting to the changing needs of the net, and that approach has worked really well. So there's really no reason for amateur network designers to say, hey, I've got an idea, let's change how the whole world works, because the internet has become sort of the bedrock on which a lot of the world functions, especially during pandemic when we can't go out and meet each other in person. Even the telephone lines that used to carry the internet now have switched, and a lot of the telephone lines are carried over the internet itself. So, of course, for those who want to, go to the valves of power, create valves and then can take control of those valves, of course they want the internet to be centrally controlled, and then they can jockey to be the person who centrally controls it. And when you control, in today's environment, you control the internet, you could control everything. So one of our recurring themes here is that you don't want to stack value beyond your ability to protect it in any central location, and that certainly includes the internet itself. So given its high value, decentralized, I think, will continue to be the way to go for quite some time. But it sounds like things are well in hand, and every time one of these things get floated, I suppose it becomes a little bit closer to sounding reasonable, but it is not reasonable. And we need to stay firmly grounded in what made the internet a success and not turn our back on that by saying, hey, let's embrace everything that is exactly the opposite of what the current design has shown to create such value for everyone. All right, with that, let's go to another clip. This is from the good people at twit.tv. This is Tech News Weekly 131. Human bias enters AI.
This is Twit.
Well, folks, we are here yet again to talk again to and about people making and breaking the tech news. And there was a big breaking story on Tuesday. 1-0, that's Medium's publication, reported that the CEO of a surveillance and artificial intelligence company called Banjo had been associated with members of the KKK in his youth, and was also involved in a shooting at a synagogue in Tennessee. That story, of course, is available on 1-0, but it brought to light kind of a bigger conversation that I happen to have been sort of having separately without this knowledge. And it's one that we regularly have. And it talks about how artificial intelligence, because of its creation by humans, which are inherently biased, results in bias itself. And I'm excited to have Dave Gershgorn here with us to talk about bias in AI. Welcome back to the program.
Thanks for having me. Great to be here.
Yeah, good. So let's kick things off. Could you give? I think we kind of got the basics down there, but could you talk about what exactly Banjo is, who or what organizations were using Banjo, and then we can kind of break into the larger story here of bias in AI.
Totally. So Banjo is a company that sells basically one product called LiveTime, and what that product does is import tons of data from different sources like social media. In Utah, they were connected to the CCTVs that the public safety department had. It was like highway traffic cameras, things like that. And this company sold event detection. So if something were to happen that was noteworthy to one of their clients, they would receive some sort of automated alert. At least that's what Banjo says. We don't have a lot of visibility into how this works, how the algorithm works. Today and yesterday, it kind of came to light that the state of Utah is pausing a lot of the contracts with Banjo, and Banjo itself is pausing its own use of its tool in Utah until the audits are able to be completed. So the the company has about 200 employees. They're based in Las Vegas and California, and they have 2 offices in Utah. So so Utah, the Attorney General had a contract with them. The Department of Public Safety had a contract with them, which was worth $20 million. And there are likely more that we don't know about.
Yeah. So, I mean, this is obviously, given the use of the product and sort of the groups that use the product, I think that's what really kind of shines a light on this. But the fact is, a lot of companies and a lot of organizations make use of machine learning, artificial intelligence, deep learning, all these different tools in different ways. And, folks might not even realize that many of their devices are making use of these types of tools day to day. So the fact is, with a system that is so that permeates our sort of ecosystem so much, we have to be aware of the biases that are in place. And I think that you described it perfectly in your article. And I don't want to give everything away. I want people to go check out the article. But could you tell us your pet metaphor? Because I think it's great.
Oh no, I have a pet metaphor? Now I have to look at my article. I did have a little something that I was thinking about in terms of predictive policing, where I think there's a really kind of classic example that is an argument against using just straight data from police in terms of predictive policing, where it has been well documented that communities of color are policed more heavily across the board. And because those communities are policed more, there's more data being fed into the machine about those communities. And crime seems higher there because there's a higher police presence, and the police are writing people up for more tickets. They are arresting more people in those areas. So the algorithm sees that glut of data from that specific community and assumes, oh, there's a lot of crime there. And then it sends the police there again. So this is a societal bias that gets encoded into an algorithm and kind of just perpetuates these kind of biases that are already present. And when I was talking to Meredith Whitaker, the co-founder of AI Now, about this, she was sure to point out that the people who lose out and the people who are persecuted more by these algorithmic systems are the people who are already being punished by society and the people who are already experiencing the harm of societal bias. So it's nothing that's necessarily new, but we're coding these systems, these societal biases and these societal systems into our software. And this is a opportunity to kind of look at the kinds of values we want our machine learning algorithms to have and strive to be better.
Yeah, absolutely. So the example that you gave is about, and it's sort of a simple explanation of how we create these tools and therefore may introduce a bias without realizing it. So I'm going to flip it on its head. You say, if you're a dog person, I am one, and so I'm biased, so I'm going to change it. If you're a cat person and you're training an algorithm with a library of cats, well, you are going to use, millions of pictures of cats as you're going through and saying, yes, this is a cat. Yes, this is a cat. Yes, this is a cat. But you might only use 1,000 pictures of a dog. So then you say, no, this is not a cat. No, this is not a cat. But if you don't have the entire scope of both of those and other animals as well, no, this is actually a ferret, not a cat, then you are going to introduce bias into the system where at times it's going to believe, oh, this actually is not a cat, and then it ends up being a cat, or vice versa. I like that, sort of breaking it down a little bit. And, you touch there on, we have these simple tools. I can remember an app that I think was, you fed it a picture and then it determined if the photo that you sent it was a burrito or not a burrito. Those are simple tools, yes. But these things go even deeper than that. And you mentioned Amazon is one instance where artificial intelligence, they've used that in the past, correct?
Yeah, so this was a report from Reuters that was about a year or two ago, and Amazon had been trying to internally develop a hiring tool that was like the holy grail was that you could feed it a whole bunch of resumes and it would give you the top 5, and then you just hire those people. That's like basically what they wanted to be able to do, but it was based on resumes that Amazon had gotten, which is like a reflection of a subsection of the technology industry, and that meant that there were a lot of similarities. The tech industry isn't known for being incredibly diverse in a lot of ways, especially in certain positions. So it was very heavily male dominated, and the algorithm was so male dominated that if there was a reference to a women's college or any part of the resume had the word woman in it, it would be downranked because these male factors were so influential in the algorithm. So that's just one example of how the training data that you have, even if you intend it to be as unbiased as possible, can kind of shade the algorithm's final decision to be different than what you intended. Amazon ended up scrapping it. They didn't use it because it didn't work. I mean, that's one of the things where if you don't have a kind of good head on your shoulders and you're not making smart decisions, I mean, it working is a kind of a subjective phrase.
Touching back on, Micah, your example with the cat, and then you mentioned, and maybe a ferret comes up along the way. The question that I have along this line is, like, maybe the creators of this algorithm never knew that a ferret was even part of the equation to begin with. Like, there was just no record. Like, they might know that a cat versus a dog, that makes a lot of sense, but ferret never even entered the picture. How can creators of these systems kind of ensure that they're focusing on everything equally, even in light of the fact that there will inevitably be variables that they could not have predicted or maybe hadn't identified yet? That seems like a big part of it too.
I agree. And I think that a lot of it is talking to a lot of people and not doing your work in a vacuum. I think it is very important for for machine learning researchers and engineers to be talking about subject domain experts and sociologists and understanding deeply how their systems work in the larger scopes of society. Audits are incredibly important, like the ones that Banjo is about to go through, according to the Attorney General of Utah's office. I think transparency, visibility, documentation, all of this is becoming a lot more of the norm as people realize that these algorithmic systems have incredible impact in our society. And I think that with transparency, with proper documentation of limitations, and being really transparent about how the algorithms are actually developed, and fostering those conversations between people who have been studying societal systems for their entire careers, and understanding how algorithms can fit into that in a better way that doesn't bring the worst of humanity into our future. I think it's critically important, and it's not something that we are unable to do. It's extremely possible if people are willing to communicate and put in the extra effort.
You're listening to Northwest Tech Show on KMUZ. That was a Creative Commons clip from the good folks at twit.tv. That was Tech News Weekly 131, Human Bias Enters into AI. And this is something we've talked about a little bit before, but it's good to kind of go back over it because algorithms have such a great impact on our lives that it really necessitates transparency and diversity in how they're handled. Like the example they gave, for a system that was being proposed to handle hiring, it's like, any reference that indicates that they might be a woman just throws that application right out, or downvotes it to the point where it's effectively done that. And, it's a garbage in, garbage out kind of thing. These AI systems, for the most part, we don't design them, we train them. And we just do, we have this model that does statistical inference. It's not really thinking the way we would consider thinking. It's just finding patterns and assigning probabilities. So you give it a set of data and you tell it how to interpret that data, and then it will find a statistical model for new data coming in and how to categorize it based on what you've already told it. So, one of the examples we like to, talk about is when, say, you're training something to find a sheep in a picture, and you show it all these pictures of sheep, and then you just show it a grassy field, and it says, "Oh, that's a sheep," because what it actually learned from all these pictures you showed it was that where there's a grassy field, it's supposed to be a sheep, and that's not what you were necessarily going for. Another interesting pattern is where it was fed. System was fed alternating images. Okay, sheep, no sheep, sheep, no sheep, sheep, no sheep. And what it determined from that was, all the odd numbered inputs are sheep and all the even numbered inputs are not sheep. And that's, again, not what you're trying to tell it, but it's what you gave it to work with. So, as algorithms really come up, in how we influence things, it's just like, it's really a way of more efficiently giving us what we've already gotten if you're not careful. So, if you're having bias against certain neighborhoods because you're over policing them, then automating your predictive crime software will indicate that you should continue to go after minorities in that area because that's what you've arrested before. Not very useful. So we have to be skeptical about these systems, not let the sort of gleam of digital magic impress us too much. As what these things are doing is generally very stupid but fast. It's doing very simple, stupid things at such incredible speed that they're actually useful, or can be useful, but they can also be very, very bad if we let them be. And again, we come back to our topic of, don't pile up value in a place where, and then not properly protect it proportional to that value. So, I'm not a fan of surveillance systems in general, but if you have one, you can't have it be all centralized control someplace, because that will put a lot of power in one place that bad people will be attracted to and try to take over and use to their advantage and everyone else's disadvantage. So you don't even have to look too many examples. That's just how people are over and over. So hopefully this stuff it really needs to get some regulation on it, again, because it really affects our lives. Those aren't things that you can just leave to the marketplace, because for the people in power, things that work aren't necessarily things that we want to work. So take care with that. All right, let's move on to the next clip. Let's talk about secure voting with Twit.tv's This Week in Enterprise Tech 391.
This is Twit.
Well, I do want to jump into the next bite for Curtis is going to go through here. And so I want to ask Curtis, how is election security evolving in the age of social distancing?
It's forgivable if it slipped the national mind during the coronavirus pandemic, but a national election is still scheduled for Tuesday, November 3rd, 2020. And there are, fortunately, still people who are focusing their attention on making sure that the election process is secure, even if those people aren't entirely confident that secure and election go together like peanut butter and chocolate. Now, I don't think that an outsider can tell you whether you're going to have a secure election. In some areas, it could happen by mail. Some are going to use voting machines, and some use a combination of these, and as well as others. And all of those mean that we're talking about many different elections rather than one election. The problem really is in our ability to audit the systems, not just electronic, but all the way down to paper systems, to make sure that they are completely trustworthy. The key is doing this in a way that reassures the voters that what they are having is a secure and reliable election while doing as little as possible to get in the way of them casting their ballot. So one of the things that many of the experts are worried about is what they call the different layers of elections, because not only are we having a presidential election, but we're going to be electing a third of the Senate, all of the House of Representatives, plus countless state and local officials. And to many ways of thinking about it, each one of those layers is a separate election. Each one has different motives, although generally affecting the way that policy is made is the goal. Each of those different layers of government affect that decision differently. Not only that, but there are multiple ways that an adversary could have an impact on the democratic process. Now, a lot of people tend to focus on the question of whether the votes will be cast, registered as they are cast, and then properly counted as they're registered. But as we saw in the last election, there are a lot of ways where an outsider can try to have an impact, whether it's through social media, stories planted in the regular media, or even other means. There are lots of layers at which they can have an impact. There are organizations, companies like Cyber Reason, who go in and do what is effectively wargaming of election scenarios. And they did one back in February where they looked at a number of these different layers. They took a look at what would happen if adversaries tried to use social media, plant stories in the mainstream media, or even manipulate the traffic signals to try and keep voters away from the polls. Broadly speaking, what they found was that it's quite easy for an outside actor to strew chaos and come back and make things difficult for a while, but that officials do have it within their capability to go back and correct for that in a sufficiently timely manner to keep the chaos from having an impact on the results. So there are a number of things here that we're going to be looking at, and one of them, I'm going to start, Brian, with you. People do become fixated on this endpoint security. That's the security of the voting mechanism, when a lot of experts say that it's the back-end systems, the database servers where voter rolls are kept, or even the email systems used by the secretaries of state that are the real points of vulnerability. Do you see any analog with that and enterprise security where people get very fixated on what's happening on the laptop and sometimes take their eye off what's going on back in the servers?
It's always that case. It's what they can see that they tend to worry about. So as a result, I personally think it's good. The low-hanging fruit is going to be those servers, because then you can have the biggest bang for the buck. So if you're going to have someone, let's go worst case scenario, say a nation state wants to mess with our presidential election. They're not going to spend all the human resources to go and mess with the voting systems unless they can do it all across the board, say with a bug. They're going to go after the databases because that's going to be the low-hanging fruit. And that's the same thing. You don't go after really the ATM machines. You go after the banking systems that are on the back end of those ATMs. So yeah, I think it's going to be the back end databases and management systems that people are going to go for.
Well, I think you're right, and I've spoken to a number of experts who make that point. Lou, I want to look to you for another question about layers of a different sort. The war game looked at a number of things like external infrastructure, traffic flow, things like social media and the impact that can have on the way people think and act on information. Do you think that issues like that should be part of an enterprise security plan as much as, say, issues of keeping malware off local systems?
Absolutely. I think that, especially ensuring you're educating your users, you're bringing them campaigns to bring them through kind of mock campaigns to basically bring them through this whole situation. We're seeing if they believe the information they see, whether it's email or, posts by users, social streams, documents, that kind of thing, to make sure that they understand that there is going to be data out there that should be fact checked and, that they don't believe anything that they basically get when it comes to emails and other kind of devices when it comes to this type of thing. And I think that should definitely be part of it. I think we actually see a lot of organizations, they implement these campaigns where they have people report specific potential malware and or spam in their email, and they see how many people actually do this reporting or how many people actually catch it, as well as how many people click on the links or even copy the data. And it's interesting. It's actually kind of crazy to see how many users actually fall for this type of thing. And so by bringing this education to your users, just making sure you provide simple guidelines for doing this, as well as services and systems to help them along the way, I definitely think enterprises will be in a better space and a better place in the long term.
You're listening to Northwest Tech Show on KMUZ. That was a Creative Commons clip from the good folks at twit.tv. That was This Week in Enterprise Tech 391, talking about secure voting in a time of pandemic. I'm Dave Duncan. And I don't want to really add too much to that. Just to say, when they were talking about social media attacks on voting, that includes the still, I think, under-addressed issue of hyper-targeting vulnerable voters with bad information. And when you do that, when you make an ad that's exceptionally false to your least informed voters, and you do it in such a way that the people that would maybe have the counterbalancing data that show that was wrong don't even know that ad existed because it was hyper-targeted, so only their intended recipients that were kind of maybe low-knowledge voters or high-bias voters would see. So that's an ad that or an issue that continues, I think, to haunt the process. And they just like things like, specifically Facebook has not really given a good answer on this. And any attempts to regulate them just say, well, we need a free hand so that we can keep the election safe. And it's like, no, that's not really Facebook's job. You're providing the technologies that allow it to be exploited, and you've got self-serving motive not to have them taken away because you're making a lot of money with them. So we really need to figure out some way to address that or cure that or do some sort of balancing information. And with that, you've done it again. You've spent an hour talking about technology and how a better understanding of it can lead to better results at home, at work, and in your civic engagement. I hope you'll join me next Wednesday and every Wednesday, noon to 1 o'clock, to continue the conversation on Northwest Tech Show.